Good afternoon, my name is Amelia Renault and this is my learning log for Math 2050. On the inside I have my title page and my learning log rules. On the next page I have my table of contents with the page, the topic, and the date. I'm going to start off after divisibility, starting with prime and composite numbers on page 39. So I'm going to skip over to page 39. Okay, these are my prime and composite numbers, and over here I have my types of prime and composite numbers with a list of each one individually. One example is prime numbers. They're greater than any number greater than 1 with exactly 2 factors is an example. On here, this is my next page. It's prime and composite numbers as well, and this is just a little helpful foldable to tell me the difference between prime and composite numbers. One example of a composite number is number 4, because it's a non-zero whole number with more than 2 factors. It has 3 factors, 1, 2, and 4, therefore it makes it composite. Moving on, this is the sieve of Eratosthenes, and I have an example here, which is this is the table that indicates all of the prime numbers on here that are not highlighted, such as 11 and 13, for example. Those are prime numbers because only 1 and the number itself make it prime. This is factors and multiples. This is factors and multiples with Cuisenaire rods, and it has each Cuisenaire rod and the color that goes with it. For example, factors of 18. We would have 18 single white blocks, color train. We have red, light green for 3, blue for 9, dark green for 6, and orange and brown make 18 because orange is 10 and brown is 8. Therefore, it would make 18. And those are all of the factors of 18. Moving along, this is greatest common divisor, and these are all different methods we can use to get the greatest common divisor. I prefer the color rods method. You have each number you're trying to figure out the greatest common divisor of, and I write the factors of each one, which would be, for instance, number 6 would be 1, 2, and 3, and number 8 would be 8, 1, 2, and 4. You look at them, and the greatest one that they have the same color rod of is the greatest common divisor. In this case, it would be 2, and that is because the last digit that will go into both of them evenly is 2. Least common multiple is similar to greatest common divisor, except not quite. For example, the least common multiple of 4 and 10 is 20. Right here, I have my 4 and my color rods and my 10 and my color rods, and the smallest number that they both divide into evenly is 20, and we can see this by drawing the Cuisenaire rods on the graph. Okay, this is some more of least common multiple. This is just a different way it's such as division by primes. Over here I have an example, a foldable. 8 and 12, for example, the least common multiple of both of these is 24. And we get this by dividing. 2 goes into 8 and 12, makes it 4 and 6. We can divide again and continue down. Then we multiply all of these numbers, 2 times 2 times 2 times 3, and that gives us 24. Moving on to integers, we have all different types of integers and ways we can use those, such as, for example, the Chinese trading as black and red chips model. Over here I have a foldable of all different kinds, but looking at the Chinese trading, we have -4 plus 2 equals -2. We would draw 4 red chips because red chips represents negative, and 2 black chips. Well, when we add those together, they cancel out, leaving us with 2 red chips, giving us -2. Okay, this is all the different properties of inner addition. I have all of them here, all different examples, and under each example I have the name. So for example, the identity property, this should be identity property. identity, because negative 4 plus 0 equals negative 4, and any integer dealing with the 0 property is identity. Okay, subtraction of integers. These are all different ways we can do subtraction of integers with examples. I prefer the pattern example. That's my favorite. It's pretty easy to figure out once you start. Say you start with 4 minus 3 equals 1, and then 4 minus 2 equals 2. Well, next would be 4 minus 1 equals 3, and so on and so forth. This is multiplication of integers. These are different types, such as chip and charge field and number line and pattern as well on this one. With multiplication, I prefer the number line method. And this is an example of 4 times negative 2 equals negative 8. On here you would start at 0, and you would do 4 groups of negative 2. So we would start 1, 2, 3, and 4 and wind up at negative 8. So 4 times negative 2 equals negative 8. Moving on, this is division of integers. And there's just a few ways to do division of integers. I prefer the set method. This is where we group the numbers into whatever, if it's negative or positive. This is one example of negative 4 divided by 2 equals negative 2. And that's a set example, and we have right here 2 groups of negative 2, which gives us negative 4 total. Okay. Moving on, we have rational numbers, and there is several different model types, and this is a helpful tool to help me remember all of the model types. It's a little envelope with all of the types listed on here. And one example is the division concept, which is 2 divided by 3. So you take for example, a piece of paper like this, and you fold it into 2/3, which means we would fold it once and fold it again. And when you open it back up, you have three different folds, and 2 of those is equal to 2/3. Moving on, this is equality of fractions with paper strips. This is much similar to what I just showed. These are all the different types. Starts with the 1/4, and then moving on to the 1/3, and the 9ths, and the 5ths and 10ths. And these are all just broken down individually, and how you can see the different, how some of them are the same. Like, for instance, 2/12 reduces down to being 1/6, and so on and so forth. This is equality of fractions. These are different methods. Excuse my toddler's scratch marks there. These are different helpful tools to be able to show 1/3, for example. Up here, 1/3, this is 3 equal parts, and one of the 3 equal parts is shaded in, giving us 1/3. This is an example of 2/3, which is also equal to 4/6 and 8 over 12, excuse me. Those all equal the same. This is fraction talk. This is helpful to be able to understand how fractions go into larger numbers, for example. Like, this is 12 equal shaded parts. Well, I shaded 4 of the 12 equal parts. Therefore, 4/12, and then I reduce that down into being 1/3, because we can take one of these and add it over here and down here, and that would give us 3 parts, giving us a whole. Okay, this is addition, estimation with subtraction and rational numbers, or fractions, for example. I love to add fractions, and this is a helpful tool to help me remember. We have split it into thirds. 1/3 plus 2/3 equals 3/3, or a whole. And I shaded it in the little heart to be able to remember, a helpful tool to know how to add. Multiplying fractions and dividing. I like to multiply by paper folding. For example, 1/2 times 3/4 equals 3/8. And this is a way for me to figure that out. We take the 3/4, we look at the bottom number as 4. So we shade in each row as red. So we're going to do 1, 2, 3 rows representing the 3. And then we look at the bottom representing 2, and we shade it as yellow, giving us 3 out of 8 shaded. So therefore, the answer of 1 divided by 2, 1/2 times 3/4 equals 3/8. Okay, moving on to decimals. Decimals are difficult to read, in my opinion. So I created a chart. Well, I redrew a chart, and this helps me remember the terminology used to describe decimals. For instance, 23.42907. That can be read as 42,907 hundred thousandths. And that's because once you start after the decimal, you go into the THS is what I like to call it. And once you get to 907, instead of saying thousands or hundreds, you would say hundred thousandths. Because once you go past that decimal point, it starts a new phrase. Okay, this is some more on decimals. These are the different squares, and enable for me to read them, I have to visualize. So this would be the 10th square, 100th square, and 1000th square. One good example would be, let's say, the 10th square. If we shaded 3 of these in, that would be 0.3. And that's because the 0.3 ends in, as I reviewed my chart before, 0.3 would end in the 10th square. So therefore, it would be on the 10th square. Over here, it would be 0.3. Okay, this is converting fractions to decimals. Or one way would be to add decimals using the decimal squares. So using the same number I said before as 0.3, we can add that to 0.2, and that would give us 0.5. And we could check our math by lining them up vertically. 0.3 plus 0.2, 3 plus 2 will be 5. Point, carry down the 0 for 0.5. Or we could shade our 3 equal parts and then add 2 more shaded parts, and then we could count 1, 2, 3, 4, and 5, and that would give us the 0.5. This is dividing the decimals and non-terminating decimals. One way we could divide, for example, 0.4 divided by 2 equals 0.2. We would take 0.4, so we would shade in 4 and divide that by 2. So 0.2 would take up 2, 0.2 would take up 2 more, and that would give us 0.2 because 0.2 goes into 4 of the equal tenths place. And then we could check our work by doing 2 divided by 0.4, and that gives us 0.2, which is exactly what we got. Okay, and that is the end of my learning log for this review. I have several other helpful methods in here to help me be able to better understand and prepare for my final. Fun little foldables really go a long way in helping remember and connect the dots to study and maintain the information and constantly keep learning about it. Thank you.